Welcome to wasmCloud Wednesday for December the 15th, 2021. As usual, we'd like to get started with the demo. Taylor, I'll hand it off to you.
Thanks, Liam. So hopefully I already have the magic sharing powers like I do. Aha! Look at that, everyone. If you're a familiar watcher of these, you'll notice that Liam assigned me the screen sharing permission. So we have successfully been, this demo has been more successful than many demos so far. Well, we'll see if that holds. This is demoing something that we will soon flip the open source button on that I have not done yet because I've been in meetings this morning for everyone to see. This is some work we've been doing at Cosmonic, and it's work that we feel would be valuable for the community around providing basically a bridge to the future for people who are currently running in Kubernetes. So what we have here is a set of hosts that are running inside of Kubernetes. This is a dashboard that if you're familiar with Kubernetes, I've port forwarded it. I'm going to be using some Kubernetes terms, so if you're not familiar with it, it's okay. This demo is probably not for you. Right here, we have several different hosts that are running. Now, the problem is you need some way for traffic to be able to get into the lattice. And so a common way to do this is to expose something using an HTTP server, no matter what it might be. So what we created are two different an actor and a provider, I should say, that are meant to be used inside of Kubernetes. The first one is the Kubernetes Applier interface. This is one that we're open sourcing. This interface has one provider implementation. I don't think it'll need more, but theoretically someone could implement a custom one for their own crazy stuff that they do at their own company, however they've customized it. But this Kubernetes Applier basically acts as a kubectl apply-f and a kubectl delete-f. So this allows for you to apply resources from within an actor. Now the service applier actor is an actor that will watch for link definitions that are for HTTP servers and then automatically create a Kubernetes service. So right now you'll actually see one in place. Let me go ahead and show all hosts. So you'll see we have the echo actors running on some of the other hosts here. And then we have the HTTP server definition. We have the HTTP server running on 4 different nodes, and I'll show what this infrastructure looks like after I show it working. And so right now I'm going to go ahead and delete this link def just so we can see that this works. And I'm going to come here and hit the enhance button. There we go, enhance. So now we have this thing running. We have kubectl service. Kubectl get service. Okay, so right now we just have some things running inside of Kubernetes, but we don't have any link definition, so that you won't see any service. So right now this service isn't accessible because we haven't linked it. It wouldn't work anyway. So let's go back here and actually define the link. So we'll link it from the echo to the HTTP server with HTTP server, and we're going to give it an address of 8081. So we're going to go ahead and submit that. So now we have this link here. And if we go back and do kubectl get services, you'll see that a service was created, listening on the port that I defined, port 8081. And so now I actually have, I'll show you ingress, just to show that this is working because I'm running this all locally. I'm using an ingress thing, and I'll output it in YAML so people see I'm not doing any funny business. You'll see that this is pointing at the service name with the path of echo. So now I should be able to do curl localhost echo, and I'll get a response back. So what you just saw in summary here is that I was able to automatically create a service that links to the newly exposed port on each of these hosts to allow traffic to come into a lattice. And so at this point, now that it's in, you can do whatever you want. Like these, you could have hosts running outside of Kubernetes, along with hosts running inside of Kubernetes. And then your things are able to talk into services that are currently existing, even if those are running external to Kubernetes. So like I said, this is meant to be a bridge to the future. We believe that in the wasmCloud project, we all believe that wasm is the future. In particular, wasmCloud is a very good way to express that future. And so this is a way for you to go from Kubernetes, which is the thing that most people are used to doing at this point, and bridge it into something when you start something new with wasmCloud. So how exactly do you set this up? Let's go ahead and look at it. There's a Kubernetes applier. Once again, this is going to be the repo that I expose in just a second, as soon as I'm done with this demo. This has all the different parts and components inside of it. But inside of the actor, I created a nice little diagram of an example architecture here, which is exactly what's set up in this example that I've been doing. So you could have, what you're supposed to have is a set of router hosts. Okay, and these hosts need to have this label right here. Wasn't for this actor. You could technically customize this actor to make it do whatever you wanted to, but it'll have this label value attached to it. And so what happens is on these router hosts, on every single router host, we spin up an HTTP server provider. So that way, anytime a link definition is created, that port will be exposed on all of those HTTP server providers across those router hosts. And so the Kubernetes service will point at those router hosts. When the service applier gets the link definition, it creates that service for you, and it will automatically route through and then be able to access wherever the actors are running on inside of your lattice. So that is the basic overview here. Are there any questions?
Taylor, what was that? Like, how did you determine the service name in Kubernetes? It's like a super long string.
Yes, this is the actor ID lowercase, so it fits Kubernetes DNS rules. So it's going to always be the actor ID. If you do some sort of, you can actually use, the intent of this actor is actually to use it as a template for wash new actor as well, so that you can basically, because it's going to be the same kind of code that you're going to use to do this. If you wanted to apply multiple resources, you're going to have to come up with a different naming scheme, which might mean you have to have like a key value store available to be able to like map some sort of randomly constructed ID to the link definition it's tied to. But because this is only doing one type of link definition, the actor ID is enough to know to basically reconstitute the ID based on the link def being deleted. And so the nice thing here is it will clean up for you. I'll show that too. I mean, I kind of half showed at the beginning, but if I go ahead and delete this and go back and do a kubecon get services, we'll see that it's gone. So this will do the management for you, and it's just using that. So the ID of the service is just the actor ID, which should allow you to be able to say, oh, this is pointing at this actor. It kind of gives you a nice way to go back and see which thing is pointing at which actor.
So is the capability provider keeping track of the node IPs of all of the potential target HTTP servers, or is it just creating a service that uses the selector to find the route servers?
It's using the selector. So in this case, this requires that label, which is the wasmCloud.dev route to label. That's a requirement to use this actor as it's compiled. But honestly, like if someone wanted to customize this for their own use case, they could pretty much fork this as is, come in here to the service, and then right here, it'll apply. So right here is where I put in the label. You could have any sort of selector that you put in for those labels. And so if you have some other set of labels that you want to match on, you could change that inside of here. That's a completely viable option. You can basically, this is the simple bare minimum. So people can take this. It's completely usable 100% as is. This isn't a toy. It can be used. But if someone wants to really customize, they could create a custom version of the applier where you could say, use these set of labels or use these very special configs or types of resources to create, like if you're using Istio or Linkerd or any of the meshes, and you need to like connect something, you could throw something in there as well. You could create that in your actor. You could have that be part of your applier. It doesn't really matter. The complexity can go up from here, but this does provide a very much a viable solution for someone who just needs to create services, which is the base unit that pretty much any of these things interact with anyway.
That's awesome, Taylor. And I look forward to getting some feedback in this on this. I know we have helped some folks get this going you know, to sort of enable the community. And I think there's, I think this is super exciting, you know, between this and the Helm chart and ultimately some of the stuff that we're working on long term. I think that we have a really good story here to help people, you know, start using the power of WebAssembly on their existing infrastructure and investments that they have today. Great. Hey, Justin. So I guess a quick around the table. I know we've had a few open source issues you know, closed, and Matt's has been contributing a bit. Is there any roadmap stuff to run through today, Steve, or do are we on hold for anything along those lines?
Well, as you saw Taylor's demo, we've gotten some community feedback that there's a lot of interest in running on top of Kubernetes. And although we're not dependent on Kubernetes, that's what people are using. So you've seen the Helm charts a couple of weeks ago, and the Kubernetes applier that Taylor just demoed. So we continue to listen to what people are doing and really want to make it work for you. I'll also say there are no patches required for Log4j vulnerability in wasmCloud. In fact, we like remote code execution. We want to run even untrusted actors. So good job, y'all. And so that's our roadmap update.
That sounds great. Brooks, do you have any good first issue callouts this week, or you still have a couple open?
I do. I've got 2 new ones for this week. We can do that right now. Maybe. If I only had. Okay. So I have 2 new good first issues. These are things that are 2 new issues that are actually, I believe they're both, well, one of them is submitted from a community member, one of them is from Taylor. But when I see things like this that are like relatively well spec'd out and like we're still working through like our prioritization for what we're doing for each sprint, I try to tag them as good first issue because it'd be a great place for somebody to come in and plug in. I'll zoom in a little bit just so it's probably easier to see. The first one is in wash. When using the wash reg commands for ping or pull or push, even if you properly use the insecure flag, if you submit an OCI reference that has like a URL scheme, so HTTP or HTTPS, this causes, I guess, an unwrap on an error value in wash. And so the specific line number is here. But it looks like this is something that, you know, when you're using an OCI reference and you include HTTP or HTTPS, which is pretty easy to do on accident, I think that wash has a good opportunity here to provide a better feedback for the user. We should be able to tell them if their OCI reference is invalid, because this is something that, you know, I've personally done before when like helping to work on the OCI distribution crate. This is something that, you know, if you mess up the way that you're specifying a reference, it could easily happen. So this is a great good first issue to get in on, especially if you're looking to just do a little bit of Rust work. And the second one is actually also a great issue to get on if you just want to do a little bit of Rust work. For those of you who have developed with wasmCloud, when you're compiling actors and providers and signing them, you may not even know, because our goal is to make it really seamless for the user, especially with our like make commands. But wash, when you're generating or when you're signing an actor or a provider, we automatically generate in-key in-key key pair for your actors and providers. So this is how we're securely signing our actors. And when we do that, we store it in your home directory at .wash/keys. And then we can further look that up in the future. And this is really just so that you don't have to deal with managing a bunch of keys when you really just want to get started working with developing wasmCloud. So the TLDR of this issue is that when we automatically generate these keys, it looks like they have a set of permissions of 644 for read, write, execute. And that should be something like 600, and the directory should be 700. So this is something, if you're familiar with some Unix file system things and have maybe poked at this at Rust before, this can be something that we may want to test on Windows. And I personally have Windows, Linux, and Mac environments. So if you're submitting an issue for this or a PR for this, and you only have a Mac or only have Linux or something like that, I'd be happy to help test that out once you submit fix. So yeah, those are our two good first issues for the community call out. These are great ways to get involved.
That is awesome, Brooks. Thank you so much for that. Just open floor. Are there any other discussion items we'd want to bring up today?
I do actually. With Elixir, there are probably questions a little bit outlandish, which I've been chasing around for a little while. Can I share my screen?
Almost there. You're on.
I think this is the right screen. All right. So I've been chasing around stuff with wasm or wadm. So this is before I get here, but basically this is a supervisor that exists that we want to have that monitors a GNAT connection. And then this is a test that I will actually show that tries to actually hydrate the state, but I haven't figured out how to do that. So I went down a rabbit hole that's actually to do with the connection state disappearing. So this is the same thing on the other side, which now opens a named connection here, and then does a supervisor tree, and it starts an initialize supervisor, and you actually call it through here. So if I go back to this guy.
Janita, we're not seeing your screen.
Oh, sorry. I missed the share button. All right, my bad. Sorry. So, so I've been working on the integration between, well, trying to work on, and the integration between the Kubernetes operator and observing the lattice, and using OAM to get the state of the lattice up and running as well as observed. What I will get to eventually is actually showing, well, trying to hydrate the state of the lattice using the application that's written by Kevin, so the lattice observer, NATS observer, etc. I did end up going down a rabbit hole, which is why I am late on this. One of the things that I actually noticed was that the genserver actually loses its PID sometimes, not always. And I've been trying to trace that through, and I don't necessarily know whether people have seen that problem before. But what I have done here is to basically copy the code out into a different area. It still has the same supervisor that's running on this side. And it still has the same name. These guys are the same. And then in the test, it actually just tries to call these two routines here. So what I actually noticed is that depending on what's actually going on, that this will actually blow up sometimes and not blow up again. And this is because I didn't save it. So in this case, it's actually saying that the PID disappeared in genserver. And I don't necessarily know why that is the case, because on the opposite side, if I do the same thing, which is running line number 7, which is this guy here, this will actually pass, but that's actually still going to the server and getting connected to the genserver that is under the name GNAT. So I don't necessarily know what's happening. And if I look at something magic like this, this is using pry to actually see what's going on. So I'm going to start mix using that method. And then if I do mix.talk.something, which is up here. That will actually try. And then if I do genserver dot where is not, that actually returns the process ID. So this has happened to me spontaneously or like randomly a couple of times. I don't actually have an explanation for why this actually happens, and happens only a few times. So that's, I've kind of left that problem around. Brooks, I see a hand up.
Yeah, I just wanted to, our resident Elixir expert, Kevin, I guess dropped off, but I wanted to, as his disciple, try and help you out. This one, if it only happens to you occasionally, especially since you're able to do that pry and like check the process ID and it exists, or like check that atom and you find the process ID. I'm curious if this is just like a race condition type of thing where the supervisor is started as a child and it just doesn't end up initializing all the way by the time you get to that part in your test. I see you have like a timer.sleep there.
Yeah.
You try that out?
Start link actually is supposed to make everything synchronous, so it's actually not supposed to return. So yeah, the timer hasn't actually, I did try it because that was my first thought as well. But then when I was reading through the documentation and looking at whether this was going to make a difference, it didn't actually make a difference. So yeah, it's just a rabbit hole that I've been chasing through. I don't necessarily know why that is the case. And it happens randomly in different places. So I'm not 100% sure. But seems like it actually works in wadm. One of the things I actually had, so, and this is back into using the lattice observer and getting the distribution manager, I think, or deployment manager working. So here I do start with supervisor, which is the same one that I was showing before. That one monitors the connection and that will actually connect here. If I go back. So this is now starting the observer, which is just going to monitor the connection, and if it goes down, it will actually maintain the name. And this dumps out. What I am not sure about is how do you hydrate the state? Because all of these are basically returning. There is nothing in here right now that's actually defined that lets you hydrate the initial state inside of the deployment manager. So if I have another test that actually runs, which doesn't even start the connection, then this is there. One of the things I actually did notice in OTP is that there is a equivalent of a, well, there's basically this handle info, which I think Kevin is using to hydrate the state. Is that something that we're planning to do here as well? And should I write that part? Or is there some other mechanism that I haven't seen that I am unaware of?
Yeah, so this is something that we have on our backlog for the Lattice observer. You know, in the OTP host and the wasmCloud dashboard, and then I guess you can also like add wadm into this now. We have like a problem where if you start them before any events start coming across the event stream, then you know you can supervise or not supervise. You can watch for those events and you can update state accordingly. But if you start something like your Lattice observer or wadm after things have happened in the Lattice, then you have to. I think you're using the phrase like hydrate your state, and we just don't have that now.
So I started it before as well, and I haven't actually noticed anything coming to the Lattice. So there is something that I'm not doing right. Well, I don't actually see the correct API, I suppose.
I think you're right. I think that wadm probably doesn't have this logic to listen for the events the same way that the host is. I think we have it in the Lattice observer now. We have it in the Lattice observer now to like observe a Lattice for events. But in terms of hydrating from the start, like if things have already happened in a Lattice, we're talking about doing something like creating a stream or like an interested stream in NATS in Jetstream that like registers interest in the wasmBus events topic. And so when you create a lattice observer for the first time, you can do things like create an ephemeral consumer for that stream. Essentially, you get to replay all of the events that have happened in the past. And that's the method that we're planning to use for like for hydrating our initial state with a lattice observer. So the lattice observer as it is today should have it has the mechanism to listen for events and populate a state. And that's what the WADM is using under the hood, right?
So I guess what I'm trying to do is actually hook everything up together. Yes, they work in terms of like the functional tests are there, but they don't actually tie all the ends in. So that's why I'm actually observing that there is no way to really hydrate the state. But yeah, if you had the cloud events come in, then that's where it actually starts because that's all mocked out. But nothing to actually listen to the cloud events on the wire, so to speak.
Yeah, all of that should be in the lattice observer side of things and not on the WADM side. But I'm actually not super familiar with where WADM is as of right now. So I may not be able to answer the question for how far that is.
Yeah. Yeah. So, I mean, okay. Yeah, like the test we have here for reconciler and stuff like that we played around with before. It works if you get the right cloud event in, and that's what I did as an initial demo. But now I'm actually trying to hook the whole thing up, and just trying to see because what I actually have is I have OTP running, and I created an after I started everything up, and I was hoping to see things come across because one of the things that's actually mentioned is that I need to define this guy here with the state changed event, which actually goes to this guy, which is an observer, which is defined in the lattice observer. And it's a callback, but it's magic. So I'm trying to figure out what the magic is.
Yes. I thought that state logic was already implemented on the lattice observer side, like with the behavior.
So I guess in the README, this is the README, right? Basically saying that once you actually do a connection from whichever application is actually using it, then you need to define a module which will get the event eventually. Hence the handle info question. It's gonna have to send it somewhere somehow. And I was hoping to just see a bunch of messages dumped out, but I know I'm not wiring it correctly, so I'm trying to figure out how to wire it.
But you don't see, even though it's stubbed out and has those logger.debugs, you don't see events come across the wire?
No, I don't.
Okay.
I mean, like when I look at the genserver, for example, there is no handle info, which I guess is where the messages actually come from right now and that part is, let me see. In here, right? So if I look at handle call, I think handle call is in here. Call. Yeah, so you have all the handle calls that actually do get prefix, get lattice. And this is all based on the messages that are already there for when you actually start the lattice, because that just starts as an empty dummy. So first question, hence the first question is like, how do you actually hydrate this? And then once you actually get messages across, either through the callback or not through the callback, something needs to work through. And like, I thought do decay was kind of there, but no, because it's still not really connecting all the way out. And then handle event was another one, which also is trying to update the state with the new state. as opposed to the old, but like the actual call out, so to speak, is missing, if I can call it that. Because yeah, I mean, well, I mean, nobody's really, this is not a pub sub thing, right? So it's actually basically something actually happens, sits on NATs, and then you try to get the messages or intercept the messages as they come through.
Yeah.
I guess jetstream is the queuing mechanism, so you can actually go and empty out the entire queue, and then go from there. But that assumes, I think, that nobody's actually consumed the messages so far. Because I think once it's delivered, it disappears, because at least that's the way I understand it to work.
Yeah, I think even though we're using Jetstream, then the NATS guarantee is still like at most 1
Right.
for message delivery. So
Yeah.
if you fire off a NATS message and there's no interested party, I think NATS is actually smart enough to not even try to send it if there's nothing subscribed. So it, you know, well, I guess it's probably being delivered to other parts of the OTP host, but yeah, it's not guaranteed to come through. Okay, well, I think that this is something that we can probably touch base with Kevin on, because it seems like there's just like one piece of connective tissue that's missing for WADM and its connection to the Lattice observer to actually get the events.
Yeah, because I think you need to be able to, I think sequencing here is probably important, because you definitely need to be able to hydrate, I think, in my opinion, and then go from there. And then actually, because I think the rest of it with the applies and all that sort of stuff are actually designed to go do things, and then reconcilers actually manage to get things back. And that, I mean, that part, once you get the events isolated, yes, that works, but it's actually just hooking up the whole thing together.
Yeah, right.
And as far as genserver disappearing, I have no idea what's going on, because it's actually happened. Like, I went down that path because I was trying this stuff initially, and it actually blew up in my face, and I tried all sorts of crazy things. I haven't really found a good solution or answer for why it actually blows up.
And that one is interesting. If it's because it's intermittent, I really thought that it was going to be like I mean, the GNAT connection supervisor can take a little bit of time after like the genserver start length like actually finishes. You can probably find in our OTP host where we like wait for it to be available at one point. But if you were sleeping for 2 seconds, it shouldn't take that long. Because I think the connection supervisor uses like it will tell you that it's done initializing and then continue to do more work, like in a handle continue, in order to actually be ready. But I would think that the genserver would be available even if the NATS connection is not yet finished. It's a lot of words to say that I don't know. That seems strange and it's unfortunate.
Yeah. Yeah, I just tried like debugging or building up Elixir to actually see whether that actually works, but that eventually takes you down to Erlang, and I don't know how to link the two things together to actually debug it all the way. Or actually, I tried and it blew up in my face, so I kind of stopped chasing that hole.
Well, one thing I didn't used to do this, but one thing I'm actually a really huge fan of is using pull requests as a way to go back and forth and collaborate. So anytime you run into something like this, feel free, even if you don't feel like whatever your contribution is or whatever is done, just to like submit a PR and tag Kevin or tag Kevin and I on it. And like, if you do that, then we can always like clone down the code that you're working with and try to reproduce. I'm happy to use like a pull request as even if you just mark it as a draft to indicate that you just are stuck somewhere, we can always use that as a collaboration mechanism.
Yeah, I think that I did that once and I forgot to sign things, and that created a bit of a mess though. But this one, I mean, I just chasing it because I was interested in how it actually worked. But I think now I'm just in the case of like there's stuff missing here.
Mm-hmm.
I'm sure. So yeah, well done.
Right, this is awesome. Yeah, and I think trying to set up a couple of paired programming sessions is super helpful as well. So we can really help to keep you enabled and unblocked here, because I think that I love all the contributions that you're really driving here, and this is going to be a really cool feature when we get this completed. So that's great. Brooks, Janitha, is there anything else you guys want to chit chat about on the call, or do we kind of pick this up offline?
We can pick it up offline. Okay,
super. Well, thank you so much for leading this work, and it's great to see all the progress that you're making. Open floor, any other call outs today that we wanted to chit chat about?
I have a game that I'd like to play with everybody.
Oh, I love games.
It's a little game of where's wasmCloud. I think I dropped this in the Slack, but I just love the idea of doing this. So anybody see where wasmCloud is at this tiny little map? I can zoom in a little bit. It might make it a little easier. I can't enhance to the point of the normal terminal enhancing, because then you couldn't see anything. This is really just a fun way to announce that wasmCloud has been donated to the CNCF as a sandbox. That stuff we've already kind of talked about for a while, but we finally landed on the landscape page. So if you take a look under scheduling and orchestration, right under Kubernetes and Nomad, you'll see wasmCloud, and you can click on that, see all of our GitHub stuff and our tweets and everything. And it's just, I wanted to, kind of show that off on the call, because it's cool being a part of the big CNCF landscape. So yeah, feel free to play your own game of where's wasmCloud at home. But it's right here under orchestration and management. If you take a look at it, we kind of felt like that was the best category for wasmCloud, because we're really, we're not only concerned with just running WebAssembly modules or like running containers or something. We're really in like the bigger space of orchestrating all of that. So yeah, that's live on the CNCF landscape.
I love it. It's great. One more thing to deliver, just transfer the trademarks and we are done. And we already qualify for the incubating tier, which is a 6-month process to go through. So we'll go ahead and kick that off and start lining up corporate partners for interviews and all that, and just be on the road map to, or on the path to being incubating. I would call out that we actually hit 90 contributors recently, which I think is incredible. That's in a year. We've been doing these, weekly meetings now. We did one every single week. We didn't miss a week for over a year. I think that's just incredible. When you think about the growth, and I think that the message is really starting to resonate. I can absolutely attest that on the corporate side, we really have a lot of excited and engaged potential large community members that we're hoping to transition in and help bring into the community. So open floor here, and then I've got maybe a couple community call outs. Anything else to chit chat about? Okay, kubecon submission deadlines is Friday, December 17th. So pull together your wasmCloud submission, even aspirational. Barcelona is still 5 months away, and get in the queue, because we'd love to have more users, more Valencia. Thank you so much. I think I tweeted Barcelona today. I should know. I'm going to be there for WebAssembly Day, of course. Now, WebAssembly Day has not opened up our CFP yet, so if you decide you'd rather do a more focused presentation, there's still time for that. And we've got a lot of fun stuff in the queue for that as well. I really look forward to the collaboration, and we'll pick up and go from there. I guess that's it for today. As usual, I'll go ahead and stop recording, and we can continue to hang out and just chit chat a little bit. But if you're watching at home, have a great day.